In this video, I'm going to show you how to solve for the zeros of a quadratic by factoring. I'm going to show you examples when a equals 1, and one example without a greatest common factor, and one example with a greatest common factor. Just as a quick refresher, a quadratic is written in standard form when it's written as such: ax squared plus bx plus c equals 0, where a, b, and c are numbers. And you'll notice all of these problems already are set equal to 0 and written in standard form, which means we can easily solve for the zeros of the quadratic by factoring. Now looking at problem 1 here, I have k squared plus k minus 30 equals 0. Remember that there's an imaginary 1 in front of these variables right here. And so a is the number that's in front of the squared term, which is 1. B is also 1. And then c is the number that's by itself hanging out at the end, which is negative 30. So that first step is to identify a, b, and c. Now we're going to use those three numbers to set up and solve an x problem. Off to the side here, I wrote that a times c goes on the top and b in the bottom. So ac top, b bottom. Now if I multiply a times c, that's 1 times negative 30, and I would get negative 30. So that goes on the top of my x problem. And then in the bottom is b. b goes on the bottom, so 1. My next step, I'm going to kind of ignore the fact that 30 is negative for a moment and just list the factors or things that multiply to get to 30. If you're not sure of those off the top of your head, what you're going to do is take 30 and divide by 1 and see if you get a nice number. Then try dividing by 2 and so on and so forth. So 30 divided by 1 is 30. So 1 times 30 is 30. That's perhaps the most obvious factor. Then I would try dividing by 2. 30 divided by 2 gets me a nice integer. It's 15. So 2 times 15 is 30. Then I would try 3. That's going to work. It would get me 10. Then I would try 4. Now if you take your calculator and do 30 divided by 4, you're going to get 7.5, which is not a whole number. So that's not going to work. So then next we would try 5. Well, 30 divided by 5 is a nice number. That number is 6. The next number to try after 5 would be 6. But notice I already have 6 and 5 as one of my factor pairs. If I did 30 divided by 6, I would just get 5. And note that 5 and 6 is the same as 6 and 5. So once we start to repeat values, we're done. We found all of our possible factors. Now, keeping in mind that the 30 is negative, I need two numbers that are going to multiply to get the top and add to get the bottom. So that means one of them has to be positive and one of them has to be negative, right? If the top number is negative, one's going to be positive and one's going to be negative. I know that the smaller number is going to be negative because I need to add to get a positive. So that means these smaller numbers here would be negative. I need to figure out which factor pair is going to add to get me 1. And again, you can try using your calculator if it's not so obvious. But what we're looking for basically is which pair are 1 apart. So these two add to get 29, 13, 7, and 1. So that means the correct factor pair to choose are 5 and 6, with the 5 being negative. So I have negative 5 and a positive 6. Now, I just want to do a quick check. Is it true that negative 5 times 6 equals equals a negative 30? Yep, that checks out. Is it true that a negative 5 plus 6 equals a positive 1? Yep, that checks out. So I have the correct factor pairs. Now I'm going to take that negative 5 and 6 along with the variable in my original problem, which is k, and use those to rewrite this part of my equation in factored form. So remember that looks like this. Two sets of parentheses with the variable, which is k, appearing here and here. And then the two solutions to my x problem, negative 5 and positive 6, going here and here. And again, the whole thing is set equal to 0. So this right here is what it looks like to write it in factored form. Now we're going to use that to solve. Remember that according to the zero product property, as long as everything's multiplied together, only one of my factors has to equal 0 for the whole thing to equal 0. So I'm going to write two separate equations, okay? One that says k minus 5 equals 0, since that's my first equation, and that's the very first term. And then another one that says k plus 6 equals 0. These are one-step equations to solve. That first one, I need to add 5 onto both sides. and 0 plus 5 is 5. Again, I added 5 because I had a negative 5 there. Boom. So we found one of our solutions. Now let's go ahead and find the other one. Again, that's a positive 6 there, so I need to subtract to solve this one. And 0 take away 6 is negative 6. So my other value, possible value for k, is negative 6. Now notice, if I look back at my problem in factored form, my solutions were just switched, the signs were switched, right? That negative 5 became a positive 5, and the positive 6 became a negative 6. So you can always use that shortcut to find your solution. There are multiple ways to express your solution. The most popular way is to use braces and write your two solutions, negative 6, comma, 5, separating each solution with a comma. You could also say, and it's totally acceptable, to write k is equal to 5, comma, negative 6, or you could write k equals 5 or negative 6, or you could separate them out if you'd like. Any of those three options are totally acceptable. Now let's take a look at an example where we have a greatest common factor. Because that's always the first thing you should do, is check for greatest common factor, especially if that a value in the front does not equal 1. You always want to try to make it equal 1, because then you can just use the x problem and avoid having to do the box. So looking at this polynomial I have here, 5n squared minus 15n minus 140 equals 0, I notice immediately that the a value is not 1, it's 5. So what we're going to do is break these down using prime factorization. I have listed to the left here some of our primes, the first 5 prime numbers. You shouldn't have to go past 11, but sometimes you will. And we're going to break these down. So notice that first number 5 is already prime. So I'm not going to try to break 5 down any further. It's already as broken down as it can get. But 15 can be broken down. So first I try dividing by my smallest prime and then work my way up as it stops working. So again, the smallest prime is 2. If I do 15 divided by 2, though, I get 7.5. So that didn't work. So I'm going to move to the next largest prime, which is 3. 15 divided by 3 is 5. So that worked. And notice that 3 and 5 are both primes. So I'm done. That's broken down as much as it can get broken down. Now looking at 140, I already broke that down for us earlier. I tried dividing by 2, and that worked. I got 70. I continued dividing by 2 because that's working so far, and I got 35. But then 35 is not even, so if you try to divide it by 2, you don't get a whole number. So then I tried dividing by 3. And when I did 35 divided by 3, I still didn't get a whole number. I got 11.666 repeating, so that didn't work. So I moved up to my next largest prime and divided 35 by 5. That worked, and I got 7, and 7 itself is also prime, note. So I finished my prime factorization of 140. Now I'm going to look to see what's common between all these pieces. Just to make it a little more obvious, I'm going to write this 5 down here because that's included. So looking to see any numbers that occur in all of these, well, it's just that 5. So now, in order to factor out that greatest common factor, I'm going to write a 5 outside a large set of parentheses. Again, the whole thing is still equal to 0. And let's see what remained. Now, looking at my very first term, I had an n squared that stayed, right? I took that 5 out, and so I still had n squared. Take a look up there to see what I'm going to separate with. I'm going to separate with a minus sign because that's what my original problem had. In that middle term, we can see that I'm left with a 3 and an n. So 3n. Again, looking back up to the original problem to see that I separate with a minus sign. And then what's left in the very last piece is the 2, and the 7. And when I multiply 2 times 2 times 7, I get 28. So now what we're going to do is just look at what is in the parentheses and treat that as our new trinomial to be factored. So now we're going to identify a, b, and c. Note that a is the number in front of the squared term, so that's 1. b is the number in front of the linear term, or the term with a power of 1, and that is negative 3. I'm including that negative sign that comes before it. And then finally, c is my term hanging out at the very end, which is negative 28. Again, I'm going to do a times c in the top. Boom, that would be negative 28. And b in the bottom. That's negative 3. Now we're trying to find two numbers that multiply to get the top number and add to get the bottom number in my x problem. Again, I'm going to ignore the fact that 28 is negative for a second and just list its factor pairs. So let's try dividing by 1. We know that's always going to work. It's 1 and the number itself, so 1 and 28. Then let's try dividing by 2. Notice right now I'm going to try all whole numbers. I'm not going to skip and just do primes like we did when we were finding a greatest common factor. I'm going to try everything. So yes, 2 works. 28 divided by 2 is 14. Then I would try 3. 3 doesn't work because 28 divided by 3 is 9.333 repeating. Let's try 4. 28 divided by 4 is 7. Then we should keep going. We would try 5 and see that it doesn't work. We would try 6 and see that it doesn't work. And the next number, 7, is already here, right? If I divide by 7, I would get 4. And 4 times 7 is the same as 7 times 4. So we're done. We found all of our factor pairs. Now again, since that top number is negative, I know that one of my numbers has to be negative and the other has to be positive. They have to have different signs to get a negative. Since my bottom number is also negative, I know that the larger of the two needs to be negative, so it's going to be one of those two. So I either have 1 and negative 28, 2 and negative 14, or 4 and negative 7. Again, it's easiest to just say, hey, I know they need to be 3 apart. If you need to actually add them all together in your calculator, that's totally fine. 1 plus negative 28, or 1 minus 28 is negative 27. That's negative 12, and that is, of course, negative 3. So this is the factor pair that works, 4 and negative 7. So I have a positive 4 and a negative 7. The order in which you write them doesn't matter, but that negative does have to be attached to the 7. So now let's write it in factored form. Don't forget to include that 5 that you took out at the beginning. That's still part of our factored form. Again, 2 sets of parentheses. The variable goes in the first slot. Notice it was n, so n goes there and there. And then a positive 4 will be there, and a negative 7 would be there. Again, these guys can swap spots. That's totally fine. Doesn't matter. Just as long as the 7 is negative and the 4 is positive. And we have all of that set equal to 0. So we can ignore this 5 out in front because notice that's multiplication, multiplication. If we divide both sides of our equation by 5, 0 divided by 5 is still 0. So that 5 really has no effect on our actual zeros. So just like before, I'm going to write 2 equations. I'm going to say each factor equal to 0. So the first one's going to say n plus 4 equals 0. And the second one is going to say n minus 7 equals 0. So n plus 4 equals 0 and n minus 7 equals 0. Again, at this point, if you can see the shortcut easily, feel free to take that. I'm okay as long as you showed all this previous work. So in that first equation, we have to subtract 4 on both sides. 0 take away 4 is negative 4. So n is equal to negative 4. That's one of my solutions. Now let's solve the other equation and try to find my other solution. Again, that's n minus 7. I need to undo the subtraction by adding on both sides. 0 plus 7 is 7. Again, those canceled, and we drop down the n. So n is equal to 7. So it's negative 4 or positive 7. Again, best way to write your solution is in braces. We usually write the smaller solution first, which is going to be the negative one. So negative 4, comma, 7 are my 2 solutions. And there you have it. That's how you can solve a quadratic by factoring when it's already set equal to 0 and in standard form, and when your a value is equal to 1.